So, my name is Matteo Manferdini. As I was saying, I'm iOS consultant. I work for different kind of clients, different kind of apps. So today I'm going to talk about the iOS toolkit, which is the base technologies you should know when you are developing for iOS. I'm not going to go very deeply into code. It's more about concepts. It's more about the main concepts that are needed mostly for every kind of app. Of course, there are a lot of technologies on iOS, and for example, there is SpriteKit, which is a lot of fun, physics engines, but that's something you're not going to use probably very often unless you make games. While there are other things that you will be using all the time when you're doing iOS development, and those are the ones I'm going to cover today. So, well, first of all, there is the big elephant in the room, which is the language that you use for developing for iOS. And the problem is there has been for 20 years Objective-C. It has served well the community. People liked it, but it was not so advanced language. Apple tried to improve it through the years. They did sometimes a good job. It was a bit slow compared to other languages. So recently they announced this new language called Swift, and everybody was completely surprised because nobody saw it coming. It's a completely new language. It takes concepts from modern languages like Ruby, like Python, things from Objective-C, things I've not seen from in other languages either. So it's peculiar to Apple like Objective-C was before. So the big question is, what language should you know now when you are developing for iOS? And well, there is a bad answer to that, which is for the moment you will have to know both, because this is transition period. And if you're writing new apps, probably you just need Swift. But there is a lot of legacy code around. So there are the whys for both languages. So why should you know Swift? Different reason. Well, first of all, it's a modern language. It's much better than Objective-C. Objective-C still works perfectly to write apps, but this is a better language for development. Apple took 3 years looking at other languages to introduce their own things. So is going to be supported from now on. It's faster than Objective-C in execution time, or at least it should be. There have been some benchmarks now that still don't stand up to promises, but it should get faster when actually is released in the future. It's much more interactive than Objective-C. There are new things possible. You can actually see your code executed while you are typing it, which is not possible with Objective-C. You can even see interfaces drawn as you are typing the code in a new feature of Xcode called Playgrounds. So it's going to help development a lot. It's going to make development a lot faster. And as I said, it's going to become the standard language in iOS. It's going to take some time, but this is the way Apple always goes. This has happened in the past. Apple switched to new technologies, and after a while they left old technologies behind. There was a bridge for Java at the beginning on the Mac. People were using it, and at some point like they dropped it. There was Carbon, at some point they dropped it. So it's going to happen with Objective-C too. It's not going to be done anytime soon, but it's going to be done. So that's why many people will be jumping on Swift as soon as possible. On the other hand, there is still Objective-C, and you should know that too, at least for now. And the reasons are, for now, all code bases are in it. I've been working for a client now for 1 year, and we have this game, and there is going to be a lot of new development. I will not go to my client and tell him, oh, listen, there's a new language. I'm going to rewrite the complete app. It took 1 year to develop in the new language. It's not acceptable. So the two languages work together, so new development will be done in Swift, but the old code base will be there, and if you have to work on it, you have to understand what's written in it. A lot of tutorial books are still in Objective-C. They will be for some time. New material is coming out, so it's not going to last very long, but to cover everything, it will still take some time. You cannot still submit apps. It's very temporary because you can use already Swift to develop apps. It works in the beta of Xcode. It will work on iOS 7 too, but Apple doesn't accept submission from betas of Xcode. So if you write Swift right now, you have to wait until September, October to submit the app to the App Store, even if it's an app that it's already been submitted. And the thing is also, they changed the language, but they didn't change any API. If you check all the APIs that Apple has developed until now, they're still in Objective-C. And it still will be for some time, at least for 1 year. At least until the next WWDC, I don't think that Apple is going to change anything in the framework. I might be wrong. They might be doing it earlier. But it means that you need to understand Objective-C to actually understand the APIs and the documentation that has been written all these years. So let's go on with the things that you actually will find in almost every app you are writing. First, let's talk about views. Views are what you actually see on the screen. Everything that is on the screen is called view. There is a class for it. It's called the UI view, and it's put into the view hierarchy. There's nothing really complicated here. View is actually a rectangle on the screen. It might have rounded corners or not. It has coordinates, which are becoming less and less important, as we will see later. Views are placed inside of other views, and of course they can have themselves other views inside of them. This builds what is called a view hierarchy, where actually the containing views, it's organized like a tree. Through the subviews property, you can access all the views inside of a view, and you can also go up the tree with the superview property. So as I said, every view on the screen is a subclass of UI view. This includes the window, which is the main, it takes the whole screen of a device. Usually you have only one window. On the Mac you usually can have more windows, but on iOS you have one only. It's not strictly true because you can have more windows maybe for printing or other things. But that is a view too. It responds to the same methods. Of course, labels when you have to write text on the screen are views, image views if you need to place images, table views, which are really important and we will see later. Any controls of buttons, text fields, switch, and of course you can write your own custom views. The views are part of the view hierarchy, but they also take part on the responder chain. The responder chain is follows the view hierarchy and intercepts every kind of event. So mainly they are touch events because they happen into views, but they can be other kind of events too, like shakes of the device or things like that. And what happens is that like the view that receives the event, if it can handle it, it does. If it can't, it sends it up back in the view hierarchy. So it will go from one view to the super view. If it's not handled, it will end up going into the window. And if it's not handled there, then it will go directly into the application. And then if it's not handled there either, it's thrown away. So this is really important. It allows to intercept events in different places of the app and to keep your code well organized. We will talk about that a bit too. So as I said, views are just rectangles on the screen. There are a lot of methods actually to place them. They have coordinate system, but this is something that personally I think it's better not to use unless needed. Of course it will be needed, but when you're developing for iOS in Xcode there is a thing called Interface Builder. It's part of Xcode. It was a separate app in the past, that's why it has a name, which allows you to draw interfaces, to place labels, to change colors for things. This is like the interface of an app that I wrote in the past, which is in the App Store. This is much faster to use. It produces much less code because code for interfaces is very verbose. So it's very long to maintain. You never know where like that color is in your code, or where that coordinate is. So if you can, try to use as much as possible interface builder. There are opposing views on this. There are people that prefer to always go through code. They say it's faster. They say it gives you more control. It's true that it gives you more control, but most of the times control is not needed. And faster is debatable, and most of the times that performance is not really needed for most of the apps you're going to write. So my suggestion is to use interface builder as much as possible. As I said, like views are placed on the screen using a coordinate system, so you can actually set the frame of a view, which is actually the rectangle taken by the view. You can put the origin of the view. You can set the center. But in iOS 6, I believe, Apple introduced auto layout. And I've seen many developers not really taking this route and actually keep doing things the old way. But auto layout in the end is much better because, again, it produces less code, and it allows you to actually not to worry about calculating placement of views on the screen, but does everything for you. What actually it allows you to do is express positions relative to other elements. So you can say this view is this distance from this other one, vertically or horizontally. You can say if it's aligned top, bottom, left, right, center, baselines for text, or give it sizes from other views. What this helps you to do is actually not worrying about all this stuff in your code, and especially when the interface changes, all these things are recalculated automatically and repositioned on the screen without you worrying about anything of it. So it's easier to express relationship between objects more than in code, because code usually is not that clear in that sense. You have less layout code because you're not making calculation. Is taken care by the system. As I said, handles reposition automatically, which is often needed because iPhones have different screen sizes. It's something not very old, it's quite recent, but there are at least 2 screen sizes. There might be more in the future, you don't know. And anyway, even if you're working on a device with the same screen size, it can rotate, especially on iPads, the screen rotates. You have to reposition all the labels, all the views on your screen, you have to resize them. So doing it through auto layout, it's much easier. So what actually auto layout allows you also to do is set constraints in interface builder. Again, like this is much easier than writing code. There are of course APIs for auto layout. They allow you to express these things in code, but in Xcode it's much easier and much faster to do. It can show you if they are contradicting each other, coloring them red, so you know it before running your app. And you can also do it directly inline without using this UI in the corner. But of course, there are things that you cannot do in interface builder. Auto layout is very powerful. The UI in Xcode is evolving. When it was for iOS 6, it was quite a nightmare to actually use auto layout in interface builder. Apple improved it for iOS 7. It's much more manageable. You can do a lot of stuff, but you cannot still do everything you can do. It's probably going to change in the future, given the direction that has been going until now. So probably Apple is going to make it possible to do pretty much everything in interface builder 2. But if you don't have the choice of doing it in interface builder because it's something more complicated, what actually auto layout is a way to express constraints on views that take this form. So you take one attribute and you create a relationship expressed like a constant multiplied by another attribute plus another constant. The second attribute is optional. So for example, you can say The width is always 500 points. But with this you can relate any attribute to any other one. So you can say this view is always double the width of this other one, or it has like a width double the height of this other one, or more complicated things. So allows to do a lot of things. At runtime, the system will take care of actually checking all the constraints and find a way to satisfy them all. If it does not, it's not possible, it degrades gracefully, so it doesn't crash your app. It just tries to remove some of them until it can actually satisfy them. But sometimes they might be ambiguous, so it might just satisfy them in ways that you don't know, so they might not be visible on screen. There are ways to debug that. We're not going into details for that. But this is the preferred way. I've seen many developers, many experienced ones, at the beginning not using it at all, and then at some point picking it up and saying, actually, now that I learned it, it makes my life much easier. It takes a while to pick it up. At the beginning, it's a bit, it has a bit steep learning curve, but it's going to help you. If you are doing it in code, there is also a language, a visual language that helps you to express constraints through strings. So of course there are methods where you can put every parameter. So in the first case, you can say like attribute is equal to this other attribute. You put all the numbers in parameters of calls, but you can also express it with this visual language that again makes it easier to read. It can create multiple layout constraints all at once. So for example, this one creates one constraint on this side and one constraint on the other side. It works both vertically and horizontally. So my advice is really to learn how this works. There is a guide from Apple, and it's pretty easy to read, and there are of course other tutorials. So having spoken about the views, which are the rectangles actually put on screen, a very important concept in iOS are view controllers. These are things that are pervasive in iOS development. You will find them everywhere. Every app you're going to develop is going to have at least one view controller. So where do these come from? Well, they come from this pattern, which is a common pattern in many different fields. It's not only iOS. The MVC pattern exists also in web development. Just to summarize it, the way Apple describes it, which is slightly different from the MVC pattern in other languages. We have a model, of course, which is the model of our app. All our business logic is inside of that. We have views that are the things on the screen. These two things don't communicate directly, but have actually in between a controller that takes care of taking information from the model and passing it to the views so it can be displayed. And of course, since we've seen views are part of the responder chain, they get information too. They get interaction with the user, so they are responsible to send back information to the controller and go to the model. This is how Apple describes it. Apple says in iOS, there is no communication at all between model and view, while in other languages there is. But this is not true anyway. I've seen that Apple goes against this rule themselves. So for example, if you take a map view and you put pins on it, yeah, well, the moment you put a bunch of pins, they are put through a view controller. You pass an array of pins. But when you move them, and like the pins are represented by model objects, by the way. But when you move them manually, there is no information that goes through controllers. Like the view directly changes the model. So although Apple says it's not done, it does it itself. It's not very often. Most of the times it goes through the controller. But in this case, actually the views are not communicating changes to controller. Of course, it makes much more sense. There is no need to communicate every single change through the controller. And sometimes you will find yourself also writing these kind of things, especially when you are manipulating objects on the screen. It's much faster to go directly to the model. But Apple describes it in the documentation the other way and says there is no exception. So in these come view controllers. View controllers are, of course, part of the MVC pattern because they are controllers, but they are a special kind of controllers. They don't only mediate this this passage of information, but they have other tasks that are expected to perform. For example, all the resource management is expected to be done inside the view controllers. And for example, auto-rotation events, they go through the view controllers. They don't go to the views. They also receive memory warnings, for example. That's why they are responsible for taking care of resource management. So for example, if your app is running out of memory, the messages for memory are going to view controllers. They also take part in the responder chain. As I showed before, the responders chain is usually done through the view hierarchy, but if a view is associated with a view controller, the message skips to the view controller before going to the next super view. So it's a way to intercept some events and take care of them not in the view hierarchy. It depends. In my opinion, is not really necessary, and I will say why. And what does a view controller do? Usually, but not always, they manage a single screen. I've seen this sometimes in some code bases I got from other developers. They were actually creating a view controller for each view on the screen. So if it was like a screen with like a big view and some little views, like let's say a profile in a social network, then you have some information and then you have the picture. I've seen people actually create a view controller for each of the single views, which is definitely not how a view controller is intended to be used, because it has a lot of overhead in the system. So what it generally does is manage a full screen, especially on iPhone. The whole screen is managed through connection through a single view controller. And when you are navigating through different view controllers, they take care to communicate between each other and to take care of the transition from one screen to the other one. They have a life cycle. I just go quickly through it. The first time they get loaded, they get this message. It's usually used to, as I said, do some resource management. This is called only the first time the view controller is created, and it's not going to be called anymore after that. Then when it's going to appear on screen, there is this event, so you can do some setup before anything gets visible. And of course, after it appeared, there is this other call. This might be called multiple times. For example, if you are navigating from in a drill down, and this is very common in iPhone, from one to the other, and then going back, when the previous one is going to appear on screen, the view will appear and view did appear are going to be called again. Of course, there is a corresponding when they are going to disappear from the screen. Before they disappeared, if you want to do some animation, and after they disappeared, if you want to do some changes in memory or unregistered listeners. There was a view did unload before, but that got deprecated, so it doesn't happen anymore. So you just get the first one, which is called only once. All the other ones might be called multiple times. So you have to keep this in mind in a view controller, especially if it's kept in memory, because I've seen many times people doing setup in these methods, especially in the view will appear and view disappear, and causing many memory leaks because they expect these ones to be run only once while actually they get called multiple times. So you should be ready for that. So there is this problem that comes out of view controllers and there is someone that calls MVC jokingly massive view controllers. The problem is that since the view controllers have a lot of responsibilities in iOS, they tend to incorporate a lot of code. So this is a problem because a view controller in an iOS app is the least usable piece of code. So the more code you're going to put inside of that, the harder it's going to actually reuse the code later. Because since a view controller is managing one screen, it's usually very specialized for that screen. It handles a lot of transitions, animations, a lot of weird interactions that you might have only in that screen. So the more code you are going to put inside of there, the bigger you're going to have the objects, first of all, which is already not a really good programming practice. But you also are going to have hard time to reuse them because sometimes they're still reusable. And to actually reuse that code, it might be easier to reuse if it's put somewhere else. So this was what I was saying. I forgot that I had like. So the guideline that you should keep in mind to avoid them to grow, and this is easier said than done, is actually to always think about them as the role in the MVC pattern. So they are a passage of information. Try to put as few business logic in them as possible. And remember that there are other type of objects in the MVC pattern, because a lot of people actually think the MVC pattern covers every object in an iOS app. So they say, well, this is not code that is related to the interface. This is not really code that is for model, because they think of model objects just as the single business entities you have in your application. So you think this code cannot go anywhere else than in a view controller. But actually you can create the different kind of objects that are just not going to be called controllers in MVC pattern. Sometimes they're called managers. There are slight variations on the MVC pattern, like there is the Model View Controller Store pattern, the MVVC, Modern View, I don't remember the acronym for that one. They are all sort of the same concept, which is you can create other objects connected to controllers, which usually don't go into the categories of MVC. And other things that also you have to keep in mind is actually UIView can be subclassed. So many times code that ends in the view controller to set interfaces, it's better put into views. Speaking of view controllers, as I said, a view controller usually handles one screen, but there are special ones which are called containers. I don't want to explain them very long. It's just good to know what they are. They usually manage transitions between two different view controllers. So the first one, the most obvious, is the navigation view controller. That's the one that you get in standard apps on on iPhone mainly. They can be used also on iPad, but are less used there. And they are the ones that actually give you the drill down. So going from one screen to the other, from left to right, and then having a back button is usually done through navigation view controllers. You can, like they do a lot of stuff automatically. And as I said, these ones, they don't manage only one screen, because these are the special cases. You have the tab bar view controllers, which are the ones that actually have a tab bar at the bottom of the screen where you actually can switch from one view controller to the other quickly. Page view controllers, they are only on iPad. They are like for sort of book apps. You can like actually turn pages like in the iBooks app. So they actually behave like a book. They even have the curl transition if you want. Split view controllers, again, iPad only. They are the ones that allow you to put two view controllers on the same screen side to side. And the popover ones that, again, are only on the iPad. That are the ones that actually pop in front of each other ones. They usually are for little controls to change properties of objects. These are only on iPad. Sometimes you see them on iPhone, but they are custom made. So this is something that many people are surprised sometimes because they think they can use them on iPhone too. For now, they are just on iPad. They might go on iOS, on iPhone too, but we don't know until Apple does it. You can also have custom view controllers. There is actually a guide on how to write them. The tendency here is to actually try to use custom view controllers as often you can, because you think, okay, I have a different case which is not one of the other ones, so I need a custom container. But most of the times, actually, you can actually use one of the previous ones for what you want to do, because transitions between view controllers are customizable, especially since iOS 7. They were already before a bit more hardly. Now there is a whole infrastructure to actually control transitions between view controllers. So, for example, you can have a navigation view controller that instead of the transition from right to left has a completely different animation. It comes from top, from bottom, fade in, fade out between view controllers. The important thing is that if you have to implement a custom one, then you have to take care of all the signaling of to view controllers where they are going to appear and disappear from the screen, which is sometimes not easy to do. While in these containers, it's already done for you. So try to use them as much as possible. While we're talking about view controllers, there is this new, I don't want to call it technology, but it's a new way of actually visualizing the app flow that Apple introduced in iOS 5 or 6, I believe, and which is called storyboards. What a storyboard usually allows you to do is to express the transition between each view controller in a visual way. So as you can see here, these are single screens of the app, which are all handled by a single view controller. And you can actually say, from this view controller, I can go to this other one. This one contains the other one. For example, this is a navigation controller that contains this one as the first one. And all the other ones are going to be pushed on the view controller through the usual transition. This gives you an eagle eye of all the transitions in your app. It's really useful, especially when you are working with different people. Sometimes I inherited projects that were doing everything in code. I had no idea what navigation was, and I had no idea to find it out sometimes because the code was not really written in the right way. So I had to put like symbolic breakpoints in view controllers to know when actually I was using the app, which ones were actually being put on the screen. So this one allows you to actually see very well where actually the transitions go and to follow the interaction in your app. Wait. Sorry. You see there are arrows between them. So as I said, each one of these is a view controller that represent a whole screen. The arrows are actually called segues, and they represent not only where actually the app is going, but they also represent how the transition happens. So they are actually objects. They can be subclassed. You can write code inside of them to take care of visual transitions. So you can keep transition code outside of view controllers. This is another way to keep them lighter. And the important thing is that they can be triggered both from the storyboard and from code using that method, which means that if you want, for example, to have a table view, like you have a list of items on one screen, and you want tapping on a cell to trigger a transition to another view controller, you can do directly inside of a storyboard. You don't need code for that. You don't need to write any code to trigger that transition. Or like using plus buttons, like to add objects and trigger other transitions. That can all be done only in Interface Builder if you want. Sometimes it's needed to be triggered through code because it happens when some other events get triggered, maybe network events or other things, then you can trigger it through the code too. A very important thing is that they create new view controllers every time. This is another thing that many people sometimes don't know or they overlook. So as you saw in the picture before, all the arrows were going in one direction. There were no arrows going back. Because if I put an arrow going from one controller to the previous one, what will happen is actually a new version of the previous view controller will be created instead of going back to the previous one. So again, I've seen this many times. People keep putting view controllers, although it looks from the navigation that you might be going to the previous one, but sometimes it's a completely new one that gets created, that gets somehow the information from the previous one. So it looks to you that you are actually going back, and at some point the application runs out of memory because you're just creating objects that link each other until you run out of memory. When a segue gets triggered, even from the storyboard, there is this method that gets called in the view controller that actually is triggering the segue. This is the place where actually you can do the configuration to the next one, because usually you need to pass some information to the next view controller. Maybe the user is selecting an element in a table view, you want to display details about that, so you need to pass to the new controller that is going to be created that information that needs to be shown. So this is the place where you do that. And usually if you want to pass data back, there is not a corresponding thing. So you use delegation, which we will see in a moment what it is for people that have never heard of it. And as I said, the UI storyboard segue is a class itself. So every arrow in the storyboard is actually an object. If you don't subclass it, then it's an instance of this class. But you can create sub-instances and change the transition, change the way view controllers get added to containers and all this kind of stuff. A very common interface element that you find in iOS apps are table views. Table views are the lists that you see in all iPhone apps, the scrolling down lists. This is something that you're going to encounter in like most of apps you develop for iPhone include at least one table view. This is just the paradigm that Apple has introduced. It's every time you see something scrolling is a table view, even though it might not look something that has separate items. It might look, for example, like the timeline of Facebook or of Path. They have different kind of elements in them, but I always table views. And before talking of table views, I want to talk about delegation, which I just mentioned. So delegation is just another programming pattern that allows an object to be configured by an external one, which is called delegate, by actually extending the functionality not through subclassing, not through composition, but through an external object that might be any kind of object that at some point in the life cycle of the app tells the object needs to be configured, I am your delegate, you should ask me for information, and then when the object actually needs the information, ask it in the precise moment that needs it. And this is very important for table views. As I said, table views are lists of items on the screen. The thing is, they are composed by cells that are created on the moment when they are needed by the table view. This is something that many people don't understand the first time. They think, I have a table view, it is a list of objects, so I just get the list of objects and give it to the table view, and then the table view will take care of displaying it on the screen. While it works the other way around. You don't give anything to the table view, you actually configure two objects which are called data source and delegate, which are the same pattern, which is delegation pattern. And sometimes they are part of the same object, which is usually the view controller that takes care of that table view. And when the table view needs information, it asks to it. So the data source responds to conforms to this protocol. And how it works is like this. You display a table view on the screen. The table view says, OK, I need to display items. First of all, I need to know how many items there are in the table view, because I need to display the scrolling. indicator, and I need to know how much to scroll. So the first thing that it asks is the number of rows. And then for each row that is visible on the screen is going to ask through this method for the cell to display on the screen. So the idea is that if there are only 4 cells displayed on the screen, the table view is going to only ask for those 4 and not for all the 100 that it might have. Which means this is very helpful when you need to fetch this data from disk, because you don't have to configure the table view passing it all the objects that you have saved, but only the ones that are displayed on screen. And this works very well with core data, as we've seen. I think that, I'm not sure, but like you might tell me, on Android I've been told it works differently. Like there is not this asking for information from a list view, which is the same thing as a table view.
Very similar.
It's very similar.
Yeah, Git view obtains the list.
Okay, because I've heard from other, maybe it was different in the past, I don't know. I've heard from other, like when I gave a workshop on this, some Android developers told me it was different.
Actually, I think most of what you're saying is very analogous
to Android. Yeah, well, very good then. It makes it easier to go from one to the other one. And this last method is actually the method you usually use in the previous one to actually create a new cell. Most of the times you create the interface of the cells inside Interface Builder, so inside a storyboard as we've seen before. You can create as many prototypes as you want and give them an identifier, which is a string, and then the moment the table view wants one of them, you actually can ask the table view to generate it for itself. So usually if you write data sources well, the table view self-forward index path is a method that has like 1 or 2 lines, not more. The other object, the delegate, is usually used for visualization. So the table view asks for height to it, of cells, for example, or it tells when actually a cell gets selected, or if it can be edited, it can be deleted. So it's mainly about visualization and interaction, while the previous one is about the data that goes into table view. As I said, most of the times these things get put into a view controller. This creates again the problem of messy view controllers. A lot of code that shouldn't be there actually is in the view controller. And Apple is actually culprit of this. If you take their example code from documentation, it does this. It sets the view controller as the delegate and the data source. Actually, there is even a class called UI table view controller, which does that automatically for you. It sets itself as delegate and data source. This makes view controllers getting very long usually. It gets like 700, 800 lines. They become massive objects. So it's really good practice to keep these two objects separated from view controllers. I thought it was going to be, tell me when, 2 minutes. Yeah. So I'm talking about too much stuff. I will keep notifications. This is just a way that objects can notify others of changes, because I want to talk about core data, which is a bit more important. You can observe properties, or you can actually send notifications from one object to different ones all at once. They register themselves as observers, and then like the object wants to send notifications, goes through them. System notifications for changes in screen, keyboard appearing. Storing data, there are different ways. If you are using system preferences, I'll go over it fast. You have preferences. They go through the NS user defaults. They allow you to set normal settings for apps. You have property list, which allows you to have files. They're really easily created. They're XML files in the interface. Quick way to store and read data from file, but it's not very helpful if you need to actually manage those objects. So that's where core data comes in. This is a framework that Apple has made to manage data in memory and persisting it on disk. This is It does a lot of stuff. Many people think it's only a database to put data in. Actually, it manages relationships. It can do track undo for you. It takes stuff from disk only when needed. It validates properties of objects. It does a lot of stuff. It can migrate from old data to new data automatically without you writing any code. And of course, it uses on disk a database. On iOS, it's only SQLite. On Mac, it can be different kind of things, but it does much more than database management systems. How it works usually is that there is a coordinator in between. It interfaces with a model where actually you describe your model of your app. So you actually create diagrams of objects, say like an employee with employer. You can actually create visual relationships with the objects. And then there is a managed object context, which is actually where these objects are stored in memory when your app is running. And this is the one you are interacting with in your code. And then the persistent store coordinator takes care of persisting things on disk. This is something you should not need to worry at all. So this is usually what you have to do in your app. You usually use the model to actually create the model of your app visually. You create the persistent store coordinator at the beginning, and then it provides you a context that you use during all the app. I wanted to talk more about this, but I don't have time. So I'm going fast. Again, manage a stack in separate classes. Apple is again culprit of this. If you create a template in Xcode with core data, it all goes into the app delegate. While you should just initialize it, but you should have separate objects for it. Because that app delegate with real controllers is another place where a lot of code just ends up and you get with a monster. This is actually, you should do it, but like, let's go over it. Let's finish it. These slides are available on my website already if you want to take them. They're not very useful for the visual part that I was going through now a bit fast, because it was just to support what I was saying. But it has this at the end, which is everything I talked about in the Apple guides. Sometimes it's very hard to know where to start with Apple documentation. So these are actually links that you can click in the PDFs to the corresponding guides. It depends on the way you learn. Usually this is the way I prefer, because they expose all the concepts you need to know about every topic and about all the things you need to know, all the APIs. But they are quite terse as documentation. They are not guides, they are not tutorials. So if you learn more by actually using something, these are not really the starting point. I learned the other way around. I usually prefer to read the general guide, and then when I am actually doing something, if I need it, I go and check it back. I've finished just now to write a book about all this stuff. It's actually an app developed from the start to publishing into the App Store. It covers pretty much all the topics that were in the slides. I still didn't announce the release date. I will do it soon. You can find it here. It's in the slides anyway. And thank you very much for listening. If there are any questions, I went through the slides a bit too fast because I was seeing the clock going on. I wanted to talk more about each one of the topics, but
you have to come back.
I love, yeah.
Yeah, I'm an Android developer, so we're used to having to do quite a lot of work when you rotate the screen. It gets destroyed and rebuilt, so it actually gives us an opportunity to have a totally different layout.
Mm-hmm.
So with the layout, auto layout and the constraints, how do you manage that so that if the screen is rotated, you just totally change it where everything is?
It depends. Sometimes you like if you want to change completely the interface, it happens in some apps. Then of course your view controller is going to be notified, and then you're going to replace it. Right. And then like of course you're writing the code to replace it. But if you want actually to resize it, for example, you have fields that are getting larger. If you express layout constraints well, usually you don't have to do anything, because the moment that it gets rotated, the window is going to change size, and everything inside of it is going to be expressed in terms of relative to the window. So like this takes the whole window, this is distant, this much from this margin, and this one. So everything gets resized automatically. You don't have to write any code. That's why I usually say use that if you can. Of course, if you want to build a completely new interface, then it's again writing the code for it. Yeah. Or writing, again, in the interface builder, you can have other files for interfaces, which is not a storyboard. You can just do a single view in a file, and then just take that and replace it on the screen.
With a simple example, like having just, when it's in portrait, the labels for fields are above, and then when it's in landscape, the labels are next to the fields. Can you do that in...
you can actually.
Oh yeah?
But the thing is, when you express constraints, they also have priorities. So you can say this constraint takes priority over this one. And then you can change the priorities. So you can actually lay out all the constraints you want, and then like when it rotates, you change the priorities constraints, and then like some of them will be ignored because other ones will be more important. Or you can actually place all the constraints and remove some when it rotates, so the other ones will take precedence. Of course, you will still have to set them with lower priority, but like this allows, this system of priorities allows the developer to put more constraints that are needed. So it and changing those actually can change the interface. But again, you're changing a few numbers, and then all the interface gets moved by itself by the system.
Okay, thank you.
You're welcome.
You mentioned something earlier about the view controllers. If you keep on adding new view controllers, that you eventually run out of memory.
Yeah.
Is there some sort of limitation to like the window stack, like how many windows you can have?
No, I don't think there is a number. I've never seen a limit. There is not any in the documentation. Usually what I've seen, you run out of memory before reaching a limit, if there is a limit. Because on iOS, like the moment you're going to run out of memory, the system is going to kill your app. It gives you like a warning. It says like you're running out of memory. Take care of that. If you don't, it sends you another warning, and then it kills your app. So I've never seen actually limits reached in terms of views or view controllers. And I've seen some badly written apps where actually many of them were actually instantiated. For example, I've seen an app where what you would do with a table view with like cells was done through view controllers. There was someone putting like a scroll view and putting view controllers inside of it for each cell. It was like a mess. It was taking a lot of memory. It was very slow for scrolling. The app still didn't crash. So because like they still didn't have enough elements, because they were just testing it with like 5, 6 elements. But that thing went on. Like I've seen like 20 view controllers all together on the screen. It still resisted. So if there is a limit, it's hard to reach.
If you navigate forward, do those old view controllers get cleaned up?
No, they stay in memory. When you go forward, all the other ones stay in memory. They keep receiving notifications. They are not on screen anymore, so all the drawing for the interface is not done. So like you don't have performance issues for those. But they still interact, they're still objects in memory. So for example, if they are registered for a notification and that comes, they receive it, and they can actually run code. When actually you go back, the ones that are going out, those are released from memory. So the moment you are going, if you like go forward, go back, and go forward again, in that case, a new one is going to be generated. So you have to also pay attention to that, because sometimes you might retain the old one in memory, then when you go forward, a new one gets created, and then you have the same problem again. You're just leaking memory. With old view controllers, you cannot even access anymore. But instead, in the same app, there was this problem too. View controllers stayed in memory, and then notifications fired, and they were all replying to the same notification. They were causing mess. So it happens.
You talked about UI table view, and obviously that the UI table view goes into the UI view,
Mm-hmm.
and that's kind of where a lot of code ends up within the UI view control.
Yes.
For the delegates. How would you set it up then if you wanted to avoid that?
What I do usually is create like an object for data source. That's good, first of all, because you're of course taking that code away and putting it in a separate object, which is more specialized. But then it's even an easier object to reuse. For example, let's say you have a data source that works with an array, very common. Then you create an array data source to which you just give an array, and then it has all the methods like count of rows and all the kind of stuff. Then when the view controller gets on screen, you just say create a new instance of it and assign it as a delegate to the table view. The thing is, like, then you can take that object and put it in another project. You just assign an array of different items and then it works. I have, for example, one that works with core data. So like a table view connected to core data, then once you've written that, you can put it in another app. What you can't do is like take a view controller and put it in another app, because then it's like too specialized. So I actually separate them in separate objects. I create a class for the data source and a class for the delegate. Sometimes the delegate, you don't need it so much because the data source is required. Those two methods that I showed, those are required methods and they're always going to be called. The delegates, they're all optional. So sometimes you need one with like 3 lines. Then in that case, I put it in the view controller, knowing that the moment I keep adding new ones, I need to move them out. But the good practice is actually create 2 separate classes for them. And like you will see that they will become much more reusable the moment you've created them.